Hey everyone, it's Justin again. In the last lesson, we learned what it means to complete the square, but we didn't learn how it's actually used. Plus, we had to break an algebra rule to do it, and we never want to do that again. In this video, you'll learn how to use completing the square to solve equations, and how to avoid breaking math rules ever again. By the end of this lesson, you will be able to solve quadratic equations by completing the square. First, I'll show you how to complete the square without breaking an algebra rule, and then we'll practice on 2 examples, along with one more example that you can try on your own. Here's a quadratic expression. Just an expression, but with one little change, it becomes a quadratic equation, which means there's a goal in mind. Find the values for x that make the left side come out to -5. Now that it's an equation, we can solve it. So let's do it. If we want to complete the square, we need to find what constant goes here. If we take half of 6, we get 3. And if we multiply those together, we get +9. The square is complete. But Justin, we broke the rules again. You're absolutely right. There we go. We aren't breaking the rule anymore. Remember, the rule is that you can't introduce a new operation on one side without also doing it to the other side. When this was just an expression, we weren't supposed to add anything to it because there wasn't another side to balance it out. Now that there are 2 sides, if we add 9 to the left side, we can also do it to the right side, and the equation stays balanced. As long as it's an equation, not an expression, we can keep both sides balanced and not break any rules. Anyway, where were we? Right, solving the equation. Now that we've completed the square, we can factor this perfect square trinomial into x plus 3 squared. While we're at it, we could combine -5 and 9 to make 4 on the right side. In order to get the x out of the square, we need to cancel it with a square root. Don't forget the rule. Do the same thing on the right side. On the left side, the square and square root will cancel out. On the right, the square root of 4 is either positive or -2. To get x by itself, we just subtract 3 from both sides. Still looks a little complicated on the right side. Luckily, we know what this means. -3 plus 2 is -1, and -3 minus 2 is -5. So the 2 solutions to the original equation, x squared plus 6x equals -5, are -1 and -5. Here's our next example. In order to use completing the square, the x term has to be subtracted so it's on the same side as x squared. And we'd need to make room for the new constant by subtracting the original constant over to the other side. Half of -8 is -4, and if we square that, we get +16. Add 16 to the other side to keep it balanced. Now we can factor the perfect square trinomial into a squared binomial, x minus 4 squared. Use a square root to cancel the square, and on the right side, remember that a square root can be positive or negative. In the last example, the square root could be simplified, but 6 is not a perfect square, so we can't simplify that, which means we'll be left with an irrational solution that can't be accurately expressed as a decimal. Finally, add 4 to both sides to get x by itself. We're left with 2 irrational solutions, 4 plus the square root of 6, and 4 minus the square root of 6. Why don't you try this one? Pause the video now and see if you can use this completing the square method to solve this equation. So, how'd you do? Did you get the solutions? First, move the 9 to the other side by subtracting. Then look at the middle term. Half of 2 is 1, and 1 squared is 1. Make sure to add it on both sides, not just the left. Now that we've completed the square on the left side, we can factor it into x plus 1 squared. Use a square root to cancel the square, and remember that a square root gives a negative and a positive. Finally, subtract 1 for both sides. The square root of 2 is an irrational number, which means our final solutions are -1 plus square root of 2 and -1 minus square root of 2. Move the constants away, complete the square, square root, and isolate the x. Pretty simple process, right? But sometimes it's a little more complicated, like with quadratics that have different numbers of solutions or leading coefficients. In the next video, you're going to learn how to use the completing the square method on more advanced quadratic equations. See you then!